Okay, we're going to take a look at the second part of the elemental composition of pure substances. So previously you looked at how to find the empirical formula of a chemical compound and how to also find the molecular formula of a compound. The other type of formula we can find is the formula of a hydrate. So a hydrate is a chemical that has water molecules trapped within the structure of an ionic compound. It is written as the ionic compound, then a dot, and then the number of water molecules. For example, Na2SO4 has the dot 10H2O. We read this as sodium sulfate decahydrate. The prefix deca tells us that there are 10 water molecules. So if it said something like trihydrate, then it would be 3 water molecules. If it said octahydrate, it would be 8 water molecules. So that prefix tells us how many water molecules. So what this means is there are 10 water molecules for every one of these sodium sulfates. So we have a lot of water trapped within this chemical, this hydrated chemical. Now, there's also the term, I'm going to go ahead and throw this in here, anhydrous, because it will pop up in your lab that you'll do after this. And that term means an means like anti, hydrous is the hydrate, so without the hydrate. So anhydrous would just be sodium sulfate without the 10 water molecules. Hydrate, or the hydrous version, would be with the 10 water molecules, just as a point of reference. So it says you may be asked to find the formula of a hydrate, which really means you're trying to find the ratio of the ionic compound to water. If you were asked to find the formula for the example given up here, you would be finding the value 10. Okay, so we would be given everything else, and we would be trying to find that number 10. Oops. So it's always a 1 to 10 ratio. This coefficient is always 1. So the ionic compound will always have a coefficient or a ratio of 1. Okay, so we're figuring out how many water molecules for one of that ionic compound. So how do we do this? We're trying to find really a mole ratio. How many moles of water are there for 1 mole of our ionic compound? So based on our given information, find the amount of the ionic compound and the amount of water in grams, and convert them each into moles. Unless they're already given in moles, then we are one step ahead. Okay. Then we will divide the moles of water by the moles of ionic compound. So we'll want water over ionic compound. The reason we want that is because this gives you the coefficient for water. It tells you how many waters per one ionic compound when we divide by that. And then we'll write our formula of the hydrate. Our example here says when 4.6 gram sample of calcium chloride, notice there's an X here instead of a number, and then it has water, so it's our hydrate, calcium chloride hydrate, is heated to form anhydrous calcium chloride. It has a mass of 0.44 grams. What is the formula of the hydrate? Okay, so we need to know 2 things to start. We need to map just the ionic compound and the mass of the water in grams. Okay, well, let's see what they did. They're taking this chemical and they're heating it. Well, when you heat it, it forms the anhydrous version, so the one without water, and it has a mass of 3.44 grams. So we have 344 grams of calcium chloride. Okay. Our original sample had 4.56 grams total. So that's the calcium chloride and the water. If we want just the water, we're going to take 4.56 grams and subtract 3.44 grams, and that will give us our mass of just the water. So 4.56 minus 3.44, I got 112 grams. and that's the water. So they heated it. That means that they're heating it up. All the water is leaving that chemical, and what we're left with is the ionic compound. So this is a very straightforward way of finding the formula of a hydrate. You will be doing a lab just like this, okay? So we've got our grams of our ionic compound, we've got our grams of water. We want to convert them each into moles. Okay. Mass to moles. So our calcium chloride has a mass of, let's see, calcium is 40.08, chlorine is 35.45. We've got two of those. So that is a mass of 110.8 grams per mole. And if I do 0.44, divide that 110.8 gives us 0.03 sig figs, so 309. So we're gonna round that to 310. Okay. So my calculator gave me 0.03099. I want to round and go to the third significant figure, this 9, and that bumps it down. Okay. That's our moles of calcium. We want to do the same thing with water. We want to go from grams of water to moles. Water has a mass of 18.02 grams per mole. So we're dividing 1.12 by 18.02 and 0.02, I'm going to round that up to 2 moles of water. Okay, now if you look at these numbers, you might even just notice that your water is about twice as much. So that's a key indicator what our ratio is going to be. So we converted both to moles. We're out of water. So water is always on the top by our calcium chloride. Okay, because we're always going to have more water than our ionic compound. Okay, and we can already see that that's going to give us a whole number of 2. So that means there's 2 water molecules for every 1 calcium chloride. So now our answer is to write the formula. Just like we did in the last section with empirical molecular, your answer is the formula. So our formula is just replacing that X with that number that we found, that ratio. Okay. Remember, our coefficient in front of calcium is just 1. It's a 1-to-2 ratio. All right. So that's how we approach it. So let's try a second one. If you want to pause and try this one on your own and then check your work with mine, that would be a great idea to see if you can kind of work your way through it. All right, so hopefully you've tried it out. So let's check it out. A student heats a 57.6 gram of hydrated zinc sulfate to drive off the water. The remaining zinc sulfate has a mass of 32.3 grams. What is the formula of the hydrate? So we know we have 32.3 grams of zinc sulfate, and our original mass was 57.6 grams. So if we subtract the zinc sulfate, 2.3, we are going to have 25.3 grams of water driven off. So we got our mass of each of the chemicals, our ionic compound and our water. We want to change each of those from grams to moles. Okay, so we need the molar mass of each. All right, so our molar mass of zinc sulfate, there is 161.47 grams per mole of zinc sulfate. So you can add up your zinc, sulfur, and 4 oxygen. So we've got 32.3 divided by 161.47. And that gives us 0.200. There's our 3 significant figures, moles of zinc sulfate. And then our water has a mass of 18.02 grams per mole. Hopefully that's when you're starting to just know. And that happens pretty quickly with water. We use it so much. And it has 1.40 moles of water. That is a pretty significant amount of water compared to our zinc sulfate. So now, again, we want to find that ratio. So again, we want water always on top, and then our ionic compound on bottom. So 1.40 divided by 0.2. So we can think about it. How many times does 0.2 go into 1.4? How many times does 2 go into 14? Should be 7 times. So that means that we have 7 times the amount of water molecules per zinc sulfate. So again, our final answer is to our formula of our hydrate. Our ionic compound always comes first. That dot to indicate kind of times, and then our 7 water molecules. So 1 zinc sulfate for every 7 water molecules. And that is our formula of our hydrate. So you're going to do in class your lab application of this, which is finding the empirical formula of a hydrate. You're going to be doing this process, heating a hydrate, finding the mass of it before and after, and determining how much water is in it. And you'll do that with a partner or group. All right? So try that out, and that'll give you some practice with this. Thanks.